So in this video, we're going to look at chapters 5, 6, and 7, which is all based on structure and bonding. Okay, when we're looking at bonding, we want to know if that bond is occurring between a metal and a non-metal or between two non-metals. Okay, remember on your periodic table, the metals are all to the left. So all of this section here are metals. And then to the right of my line here, I've got the non-metals. Hydrogen also counts as a non-metal. So when I'm asking myself, do I have a metal and a non-metal? I'm asking myself, do I have elements that are on opposite sides of this line? Okay, if I have one element from over here and one element from over here, I've got a metal and a non-metal, and this is going to be ionic bonding. On the other hand, if I've got two non-metals, so two elements from this side of the periodic table, or hydrogen, then I say I've got covalent bonding. Okay, we're going to look at the two. We're going to look at ionic bonding and we're going to look at covalent bonding. So we'll start with ionic bonding. Okay, I'm just going to draw you a little example. Okay, it's between a metal and a non-metal. I'm going to draw you an example of a metal, and the metal I'm going to draw is lithium. Okay, so I'm going to put Li, and I'm going to draw a circle for the electrons. If I wanted to know how many electrons lithium has, I would look at my periodic table. Okay, I would see that the atomic number or the proton number is 3, and I know if the number of protons is 3, the number of electrons is also 3. Okay, but when I'm drawing my lithium, instead of drawing all of my electrons, I'm only going to draw the outer shell because it's only the electrons in the outer shell that actually react. Because lithium is in group 1, I know it's got 1 electron in its outer shell. So instead of drawing all 3 electrons, I'm just going to draw the outer shell, and the outer shell has 1 electron. Okay? Lithium wants to have a full outer shell. And in order for this to happen, it's going to lose the only electron that it has in the outer shell. It's going to lose 1 electron. Okay? I'm going to draw lithium reacting with a non-metal. The non-metal I'm going to choose is fluorine. Okay, fluorine is over here, and I can see that it's got 9 electrons in total. But again, I only care about the electrons in the outer shell. So instead of drawing all 9 electrons, I'm just going to draw 7. How did I know that fluorine has 7 in the outer shell? Because it's in group 7. And if it's in group 7, there are 7 electrons in the outer shell. So I'm going to draw 7 electrons for fluorine. Okay, fluorine also wants to have a full outer shell, and a full outer shell is 8 electrons. It's got 7, it wants 8, it will gain 1 electron. So you've got lithium that wants to lose an electron, you've got fluorine that wants to gain an electron. So they will react with each other because they can make each other happy. Lithium will give fluorine its electron. So when I draw lithium, I'm going to draw it with no electrons because it's given its outer shell electron away. And I'm going to draw fluorine with its 7 original electrons, which I'm using dots for, and an extra electron that I got from lithium. Because lithium has lost an electron, it has a positive charge. Because fluorine has gained an electron, it has a negative charge. There's an attraction that holds something positive to something negative. And this attraction is called the electrostatic attraction. So I can say I've got an electrostatic attraction between the positive lithium and the negative fluorine. Okay? And when they become positively or negatively charged, instead of calling them atoms, we start to call them ions. So I can say I've got electrostatic attraction between oppositely charged ions. Okay, this attraction is very strong. It is a strong attraction. And if the attraction is strong, those particles are going to be held really, really closely together. If those particles are held really closely together, okay, and they're all held together nice and tight and they're all touching each other, okay, they're going to look like this. And we should hopefully know from CC1 revision that this is the particle diagram for a solid. So if you've got a strong attraction between the particles and they're held really closely together, then you are going to end up with a solid. So I can say that lithium fluoride, which is what this is called, is going to be a solid at room temperature. And the reason it's solid is because there's a very strong attraction between the particles. The name of this strong attraction is the electrostatic attraction, and it's between oppositely charged ions. Okay, it means ionic compounds are going to be solid at room temperature. Okay, I'm going to look at the other type of bonding now. I'm going to look at covalent bonding between two nonmetals. So I'm going to use chlorine as an example of a nonmetal. Chlorine is in group 7, just like fluorine. So just like fluorine, I'm going to draw 7 electrons in the outer shell. Okay? Chlorine wants to gain 1 electron because it's got 7 and it wants to have 8. I'm going to show chlorine reacting with another chlorine. Okay, remember covalent bond is 2 nonmetals reacting together. Chlorine is a nonmetal. I've got 2 chlorine atoms. They both want to gain 1 electron. Okay, so you see we have a bit of a, it's different from what we had above. Okay, above you had a metal that wanted to lose an electron and the non-metal that wanted to gain. So the metal could just give the non-metal its electron and everyone ended up happy. Down here I've got 2 non-metals. They both want to gain, neither of them want to lose. So the only way that they can react and make each other happy is if they choose to share their electrons. And because they're sharing, I'm going to draw their outer electron shells overlapping. So it's very different from what I drew up here. I'm drawing those outer shells overlapping. And this section in here in the center represents the electrons that are shared, the shared electrons. And I need to know how many electrons I'm going to draw on the shared bit and how many electrons I'm going to draw on the outside. If chlorine wants to gain 1 electron, it is willing to share 1 electron. And this chlorine is exactly the same. It wants to gain 1 electron, so it will share 1 electron. So I've got 7 dots that I need to draw over here. It wants to share 1 electron, so I'm going to draw 1 dot in the center. But the other 6 dots I'm going to draw on the outside. Those electrons are not going to be shared. So 6 on the outside, 1 in the center. Then I've got this chlorine who also wants to share 1. So I'm drawing 1 cross in the center. The other 6 crosses I draw on the outside. They are not going to be shared. Okay? And this I call a chlorine molecule. Okay, so this here, the shared electrons, that's a covalent bond and it holds the molecule together. Okay, if I look at, so I'm going to write this underneath, this is a simple molecule. Okay, simple molecules are held together by weak intermolecular forces. Okay, it's the only weak force we look at. Weak intermolecular forces hold simple molecules together. And because these forces are weak, you don't need a lot of energy to break them apart. Because you don't need a lot of energy to break the particles apart, okay, the particles are going to exist far away from each other, okay, and they are going to be gases, okay. So simple molecules are gases at room temperature, but ionic compounds, they were solid. The reason these guys are solid is because you've got a strong attraction that holds the particles together, but down here you've got a weak force, the particles are spread out, and when they're spread out, that is a gas. Okay, so you'd expect simple molecules to be gases at room temperature. The other property that we can look at is whether they will conduct electricity or not. Your simple molecules don't conduct electricity. Okay? In order to conduct electricity, you need to have charged particles that can move freely. There are no charged particles here. I've got no pluses, no minuses. I've got no charged particles, so this is not conducting electricity. Up here, I do have charged particles, plus and minus, But those particles do not move freely in a solid. Remember, particles in a solid can only vibrate. So if I wanted this to conduct electricity, then I would need to turn it into a liquid first so that those ions could move. All right. There's one other type of covalent. So I've shown you covalent bonding in a simple molecule, but you need to know that there's also something called giant covalent. And your examples of giant covalent are diamond and graphite. And the properties of diamond and graphite are different than the properties of our simple molecules. Diamond and graphite have high melting points. So lots of energy is required to melt diamond and graphite. They're strong. Okay, they're strong with high melting points. Okay, for diamond, okay, I could also say that it was very hard. So diamond is hard, strong with a high melting point. Graphite is not hard. It is strong and it's got a high melting point, but it is a slippery solid. Okay, so diamond is hard with a high melting point and it's very strong. Graphite is slippery with a high melting point and it's very strong. So they're your giant covalent and they differ from the simple molecular. Diamond and graphite are both made of the element carbon. So on page 16 of your core info guide, there are 12 questions, okay? I haven't gone through all of the information you need for these questions in the video, but anything that I haven't talked about, you will find within the guide, okay? First two questions, you're asked to draw a dot and cross diagram. Then you're asked, what is a covalent bond? Make sure you're getting your answer from here, okay? Don't just make up the definition yourself, okay? And then the other questions you will also find in this information right here. So have a go, press pause, answer these 12 questions for yourself. And then when you're ready to go through the answers, when you've done your best and answered all questions, then press play again. So I have gone through all of the answers on the same page, page 17. So I've drawn the diagrams for you, the dot and cross diagrams, okay? And I've given you all of the answers, okay? I think most of the answers should be relatively straightforward from the information that I have given you, okay? So when you're marking your work, make sure you check that you're using the same keywords that I am using, okay? Okay, so that is structure and bonding, okay? Know that metal and non-metal is ionic and two nonmetals is covalent. You absolutely need to learn that fact off by heart.